Your doctor has 7 minutes with you. 7 minutes to review your symptoms, check your vitals, renew your prescriptions, and send you on your way. In those 7 minutes, there is no time to talk about the habits that are quietly, systematically dismantling your health from the inside out. Not because your doctor doesn't care, but because the system wasn't built for that conversation. I am going to have that conversation with you today. I'm Dr. Julian Cross, and in this video, I'm going to walk you through 5 habits that the majority of adults in the developed world practice every single day that are accelerating disease, aging your cells faster than your birth certificate says you should be aging, and increasing your risk of the exact conditions your doctor is trying to treat you for. These are not obscure habits. They are not rare. In fact, I would bet money that you are doing at least 3 of them right now, possibly all 5. And here is what makes this conversation different from most health content you'll find online. I am not going to sell you a supplement. I am not going to push a program. I am going to give you the science, the mechanism, and the fix, straight. Stay with me until habit number 5, because that one is the one that nobody is talking about, and in my clinical opinion, it may be the most dangerous of all. Welcome back to the channel. If you're new here, I'm Dr. Julian Cross, and this channel exists because the healthcare system is structurally incapable of giving you the preventive health education you deserve. Not because of bad doctors, because of bad incentives, time constraints, and a system designed around treating disease rather than preventing it. Today's video is about prevention. Specifically, it's about 5 behaviors that are so normalized in modern life that we've stopped recognizing them as harmful. We've built entire industries, social rituals, and daily routines around them. And the cost is showing up in our biology. Before we start, a quick disclaimer. This video is educational. It's not personalized medical advice. If you have existing health conditions, please work with your physician. What I'm sharing today is based on peer-reviewed research, and I'll walk you through the mechanisms so you understand exactly why these habits are harming you, not just that they are. Let's get into it. Habit 1, chronic sitting. Habit number 1 is sitting. And before you roll your eyes, I need you to understand that I am not talking about sitting for an hour. I am not talking about a sedentary afternoon. I am talking about the 8, 10, 12 hours of near continuous sitting that has become the default state of modern adult life. There is a phrase that has entered public health literature over the last decade that I want you to understand deeply. The phrase is this: sitting is the new smoking. I know it sounds like an exaggeration designed to get clicks. It is not. Let me give you the biology. When you sit for extended periods, several things happen in your body simultaneously. First, lipoprotein lipase activity drops dramatically. Lipoprotein lipase is an enzyme produced primarily in your skeletal muscles, and it is responsible for breaking down triglycerides in the bloodstream and clearing fat from your circulation. When you sit, muscle contraction stops. When muscle contraction stops, lipoprotein lipase activity can drop by up to 90% within the first hour. That means fat that should be cleared from your blood is instead circulating, depositing in arterial walls, and contributing to cardiovascular disease. Second, insulin sensitivity plummets. Your skeletal muscles are the primary site of glucose disposal in the body. They account for roughly 80% of postprandial glucose uptake. When those muscles are inactive, glucose has nowhere to go efficiently. Blood sugar stays elevated. Insulin is secreted in higher quantities. Over time, the insulin receptors on muscle cells become desensitized. You develop insulin resistance. And insulin resistance is the upstream driver of type 2 diabetes, metabolic syndrome, non-alcoholic fatty liver disease, polycystic ovarian syndrome, and is increasingly implicated in Alzheimer's disease, which some researchers now call type 3 diabetes. Third, something happens structurally in your vasculature that most people have never heard of. When you sit, particularly with your legs bent at 90 degrees for extended periods, endothelial function is impaired. The endothelium is the single-cell thick lining of your blood vessels. It regulates vascular tone, clotting, inflammation, and the trafficking of white blood cells. When blood flow through your lower extremities slows significantly during prolonged sitting, endothelial shear stress drops. This triggers endothelial dysfunction. Nitric oxide production declines. Vessels become less capable of dilating appropriately, and endothelial dysfunction is the first step in the development of atherosclerosis. A landmark study published in the Annals of Internal Medicine analyzed 41 studies involving over 800,000 subjects, and found that people who sat for the longest periods had a 24% greater risk of colorectal cancer, a 32% greater risk of endometrial cancer, a 91% greater risk of type 2 diabetes, and a 147% greater risk of cardiovascular events compared to those who sat the least. These are staggering numbers. Now, here's the part that genuinely disturbed me when I first encountered the research. Exercise does not fully compensate for prolonged sitting. This is the counterintuitive finding that changes everything. Studies have shown that people who exercise for 1 hour daily but sit for the remaining 15 to 16 waking hours still show significantly elevated cardiometabolic risk compared to people who move regularly throughout the day. Your 1 hour gym session does not undo 10 hours of sitting. The biological damage from prolonged, uninterrupted sitting is partially independent of total exercise volume. What the research does show is that the solution is interruption. Breaking sitting time with as little as 2 to 5 minutes of light movement every 30 to 45 minutes dramatically restores endothelial function, reactivates lipoprotein lipase, and significantly blunts the glycemic effects of prolonged sitting. A study from the University of Queensland demonstrated that 2-minute light walks every 20 minutes reduced postprandial blood glucose by 39% compared to continuous sitting. That is a profound intervention that requires nothing more than standing up and walking to the kitchen and back. Practical protocol. Set a timer for 30 minutes while working or watching television. When it goes off, stand up. Walk for 2 to 3 minutes. That is it. That one behavior change will meaningfully alter your cardiometabolic risk profile over months and years. It costs nothing. It requires no equipment. It just requires that you stop normalizing sitting as a neutral activity, because it is not neutral. It is actively harmful when prolonged and uninterrupted. One more thing on sitting. Sitting also impairs lymphatic circulation. Unlike the cardiovascular system, which has the heart as a dedicated pump, the lymphatic system relies almost entirely on muscle contraction and movement to propel lymphatic fluid through the body. Lymph fluid carries immune cells, clears cellular debris, and transports dietary fats from the gut. When you sit for hours, lymphatic flow essentially stagnates. This contributes to systemic immune dysfunction, poor cellular waste clearance, and chronic low-grade inflammation. Bottom line on habit 1, sitting for extended, uninterrupted periods is a genuine metabolic toxin. Treat it accordingly. Habit 2, chronic stress without intervention. Habit number 2 is not having a stress response. Stress responses are normal, adaptive, and essential to survival. Habit number 2 is living in a state of chronic, unresolved psychological stress without any deliberate intervention to regulate the nervous system. And before anyone turns this off thinking I'm about to recommend yoga and journaling, stay with me, because I'm going to explain exactly what chronic stress does to your body at the molecular level. And by the end of it, I think you will treat stress management as a hard medical intervention rather than a soft lifestyle preference. Here is the mechanism. When you perceive a threat, whether it is a physical danger or an email from your boss, your hypothalamus activates the hypothalamic pituitary adrenal axis, commonly called the HPA axis. The hypothalamus signals the pituitary gland, which signals the adrenal glands, which release cortisol into the bloodstream. Simultaneously, your sympathetic nervous system activates the adrenal medulla to release adrenaline and noradrenaline. Heart rate increases, blood pressure rises, glucose is mobilized from the liver, digestion is suppressed, immune function is downregulated in the short term. Your body is preparing to fight or flee. This system is extraordinary in acute situations. The problem is that the human body was never designed to have this system running continuously, at low levels, for hours and days and weeks and years. And that is exactly what chronic psychological stress produces. What does prolonged elevated cortisol actually do to your body? Let me walk you through it systematically. First, cortisol is profoundly immunosuppressive over time. It downregulates the production of cytokines, impairs T-cell function, reduces natural killer cell activity, and shrinks the thymus. In the short term, this is useful. You don't want a major immune response in the middle of fleeing from a predator. But chronically suppressed immune function means you get sick more often, wounds heal more slowly, cancerous cells are less efficiently identified and destroyed, and viral latency reactivation rates increase. People under chronic stress reactivate dormant viruses like Epstein-Barr and cytomegalovirus at far higher rates than unstressed controls. Second, chronic cortisol elevation drives what's called cortisol-induced insulin resistance. Cortisol is a glucocorticoid, meaning it raises blood glucose. It does this by stimulating gluconeogenesis in the liver, reducing glucose uptake in peripheral tissues, and directly antagonizing insulin signaling. This is fine for an acute stress response. But when cortisol is chronically elevated, it continuously pushes blood glucose up, forces the pancreas to secrete more insulin, and over time produces insulin resistance and beta cell exhaustion. Chronic stress is a direct mechanistic driver of type 2 diabetes that has nothing to do with diet. Third, chronic stress accelerates cellular aging through telomere shortening. Telomeres are the protective caps on the ends of your chromosomes. Every time a cell divides, telomeres shorten slightly. When telomeres become critically short, the cell enters senescence or apoptosis. Telomere length is therefore a marker of biological aging. Alyssa Epel and Elizabeth Blackburn, who received the Nobel Prize for telomere research, demonstrated in landmark studies that chronic psychological stress is directly associated with accelerated telomere shortening. The perceived stress scale scores of caregivers, for example, correlated with telomere length differences equivalent to 10 additional years of biological aging. Chronic stress is literally aging you faster at the chromosomal level. Fourth, and this one often surprises people, chronic stress causes structural changes in the brain. The hippocampus, which is the region critical for memory consolidation and emotional regulation, is densely populated with cortisol receptors. Under chronic cortisol exposure, hippocampal neurons undergo dendritic atrophy, synaptic pruning, and eventually neuronal loss. Studies in people with major depressive disorder, which is frequently driven by chronic HPA axis dysregulation, show measurable hippocampal volume reduction. Chronic stress also increases amygdala reactivity, which makes you more sensitive to perceived threats, which perpetuates the stress cycle in a self-reinforcing loop. Fifth, cardiovascular system. Chronic activation of the sympathetic nervous system elevates resting heart rate, increases arterial stiffness, promotes endothelial dysfunction, increases platelet aggregation, and drives hypertension. A meta-analysis of prospective studies found that job strain, a proxy for chronic occupational stress, was associated with a 23% increased risk of myocardial infarction. Now, what is the intervention? Because identifying the problem without a solution is useless. The most evidence-backed intervention for chronic stress is not medication. It is structured activation of the parasympathetic nervous system, your rest and digest counterpart to the sympathetic fight or flight response. And there are several ways to do this that have genuine, rigorous evidence behind them. The most accessible is physiological sighing. A double inhale through the nose, followed by a long exhale through the mouth, activates pulmonary stretch receptors and produces rapid parasympathetic activation. A randomized controlled trial published in Cell Reports Medicine in 2023 found that 5 minutes of cyclic sighing daily reduced anxiety scores, improved HRV, and produced significantly better mood outcomes than mindfulness meditation. 5 minutes, free, available anywhere. Mindfulness-based stress reduction, when practiced consistently over 8 weeks, produces measurable reductions in cortisol, improvements in HRV, reductions in amygdala reactivity on fMRI, and significant improvements in inflammatory markers including IL-6 and C-reactive protein. This is not anecdote. This is controlled trial data. Cold water exposure, even brief cold showers, activates the diving reflex and produces rapid parasympathetic dominance following the initial sympathetic spike. Regular cold exposure has been shown to increase norepinephrine levels by up to 300%, which improves mood, focus, and stress resilience over time. The point I want to make before moving on is this. Stress management is not a luxury. It is not something you do when you have extra time. It is a hard medical intervention that directly affects your inflammatory burden, your hormonal balance, your cardiovascular risk, your immune competence, and the rate at which your cells are aging. Treat it with the same seriousness you would treat taking a medication. Habit 3. Ultra-processed food consumption. Habit number 3 is eating ultra-processed foods as the foundation of your diet. And I want to be specific about what I mean by ultra-processed, because not all processed foods are equal, and the distinction matters. The NOVA classification system, developed by researchers at the University of Sao Paulo, divides foods into 4 categories based on the degree and purpose of processing. Category 4, ultra-processed foods, are defined as formulations made mostly from substances extracted from foods or derived from food constituents. They include industrial oils, modified starches, hydrolyzed proteins, artificial flavors, emulsifiers, preservatives, colorants, and other additives designed to make the product hyperpalatable, shelf-stable, and highly profitable. These are not foods that happen to be processed. These are engineered products designed by food scientists to override your satiety signals, your taste preferences, and your appetite regulation systems. And they are extraordinarily effective at doing exactly that. What does the research say? A landmark randomized controlled trial published in Cell Metabolism by Kevin Hall and colleagues at the NIH in 2019 directly compared ad libitum consumption of ultra-processed versus unprocessed diets in matched subjects. When given unlimited access to ultra-processed foods, subjects consumed on average 508 additional calories per day compared to the unprocessed diet group, despite the meals being matched for total calories, sugar, fat, fiber, and macronutrients on paper. They ate more, they ate faster, and they gained significantly more body fat. When switched to the unprocessed diet, they spontaneously reduced caloric intake and lost weight without being told to restrict. The food environment drives eating behavior, not willpower. But the effects of ultra-processed food go far beyond caloric overconsumption. The microbiome impact is catastrophic. Your gut microbiome consists of approximately 38 trillion microorganisms that regulate immune function, produce neurotransmitters, synthesize short-chain fatty acids that maintain gut barrier integrity, modulate inflammation, and influence everything from mood to cardiovascular risk. Ultra-processed foods feed the wrong bacteria, specifically gram-negative proteobacteria that produce lipopolysaccharide, which is an endotoxin that triggers systemic inflammatory responses when it crosses the gut barrier. Meanwhile, the fiber deficiency in ultra-processed diets starves the bacteria that produce butyrate, a short-chain fatty acid that maintains the gut epithelium, regulates immune responses, and has anti-cancer properties. A study published in Nature found that high consumption of ultra-processed foods was associated with dramatic reductions in gut microbiome diversity within 2 weeks. Loss of microbiome diversity is one of the most consistent findings across chronic diseases, including inflammatory bowel disease, obesity, type 2 diabetes, cardiovascular disease, and depression. The emulsifiers in ultra-processed foods are worth a specific mention because they receive far less attention than they deserve. Emulsifiers like carboxymethylcellulose and polysorbate 80, which are ubiquitous in processed foods, directly disrupt the mucus layer that lines the intestinal wall. This layer is your first physical barrier against luminal contents entering the bloodstream. When it's disrupted by emulsifiers, bacteria and bacterial products translocate into systemic circulation, triggering low-grade endotoxemia and chronic inflammation. Research in mouse models showed that these emulsifiers induced metabolic syndrome and inflammatory bowel disease in otherwise healthy animals. Human data is emerging and is concerning. The artificial flavor and reward system manipulation deserves its own mention. Ultra-processed foods are specifically designed to hit the bliss point, a term coined by food scientists, which represents the precise combination of sugar, fat, salt, and textural properties that maximally activates dopamine release in the nucleus accumbens. The dopaminergic response to ultra-processed food has been compared in neuroimaging studies to the dopamine response to addictive substances. The orbitofrontal cortex, which mediates reward valuation, shows similar activation patterns to those seen in substance use disorder. This is not a character flaw in people who struggle to stop eating these foods. This is neurochemistry, deliberately engineered by billion-dollar corporations. What is the practical solution? It is not perfection. It is not that you can never eat a processed food again. The research consistently shows that the dose makes the poison here. The threshold that appears to produce measurable harm is when ultra-processed foods constitute more than 20 to 25% of daily caloric intake. Below that threshold, the data on harm becomes much less robust. The single most effective dietary change most people can make is to prepare more food from whole ingredients at home. Not because home cooking is inherently virtuous, but because it is structurally impossible to replicate the specific combination of industrial additives, emulsifiers, and engineered hyperpalatability in a home kitchen. When you cook your own food, you are automatically eating less ultra-processed product. Full stop. A simple rule that I share with patients: if the ingredient list has more than 5 items and contains words you cannot pronounce or would not find in a standard kitchen, it is ultra-processed. Treat it as an occasional food, not a dietary staple. Habit 4. Chronic sleep deprivation. Habit number 4 is treating sleep as optional, as something to be squeezed into the gaps between productivity, as a sign of laziness if prioritized, as something to catch up on at weekends. Every single one of these beliefs is not just wrong, it is medically dangerous. Matthew Walker, the neuroscientist at UC Berkeley and author of Why We Sleep, has a phrase I want to embed in your mind. There is no aspect of your health that is not made better by more sleep and made worse by less sleep. And the research he references is comprehensive. Let me walk you through what sleep deprivation actually does to your physiology, because I think once you understand the mechanisms, you will never casually sacrifice sleep again. First, immune function. During sleep, particularly slow-wave sleep, your immune system undergoes what is essentially a maintenance cycle. Natural killer cell production increases dramatically. Cytokine profiles shift toward adaptive immune function. T-cell activity peaks. A famous study from the University of California showed that people sleeping 6 hours a night were 4 times more likely to develop a cold when experimentally exposed to a rhinovirus, compared to those sleeping 7 or more hours. Sleep is your most powerful immune intervention, and you cannot buy it in a supplement form. Second, metabolic consequences. A single night of sleep deprivation has measurable metabolic effects. Research shows that after one night of shortened sleep, insulin sensitivity decreases by up to 25%. Ghrelin, the hunger hormone, increases significantly. Leptin, the satiety hormone, decreases. The prefrontal cortex, which governs impulse control and rational decision-making, shows reduced activity, making food choices significantly worse. Studies tracking caloric intake show that sleep-deprived subjects consume on average 300 to 500 additional calories the following day, strongly favoring high-sugar, high-fat, ultra-processed foods. Sleep deprivation and poor diet are therefore not independent habits. They are a reinforcing cycle. Third, cardiovascular risk. A meta-analysis of over 470,000 participants published in the European Heart Journal found that sleeping fewer than 6 hours per night was associated with a 48% greater risk of developing or dying from coronary artery disease and a 15% greater risk of stroke. Chronic sleep restriction raises blood pressure, elevates sympathetic nervous system tone, promotes endothelial dysfunction, and increases inflammatory markers. Your heart pays the price for every hour of chronic sleep debt. Fourth, and this is the one that I think is most alarming from a public health perspective, the neurodegenerative consequences. During sleep, your brain activates the glymphatic system, a network of channels surrounding cerebral blood vessels that functions as the brain's waste clearance system. During slow-wave sleep, glymphatic flow increases dramatically, flushing metabolic waste products from the brain, including amyloid beta and tau proteins. Amyloid beta is the primary component of the plaques found in Alzheimer's disease. Tau is the protein that forms neurofibrillary tangles, the other hallmark of Alzheimer's pathology. Chronic sleep deprivation impairs glymphatic clearance, leading to amyloid beta accumulation in the brain. Research using PET scanning has shown that a single night of sleep deprivation produces measurable increases in amyloid beta deposition in the prefrontal cortex and hippocampus in healthy young adults, not in elderly patients, in healthy young people, after one bad night. Imagine what years of chronic sleep restriction does to the cumulative amyloid burden. There is now substantial epidemiological evidence linking chronic sleep deprivation earlier in life with significantly increased Alzheimer's disease risk decades later. This is not a peripheral concern. Alzheimer's disease is the most feared condition among aging adults. Sleep is one of the most powerful modifiable risk factors we have identified. Fifth, hormonal disruption. Testosterone is primarily produced during sleep, specifically during REM sleep. Growth hormone is almost entirely secreted during slow-wave sleep. Melatonin, your master circadian hormone, is produced in the dark, but its secretion pattern is profoundly disrupted by irregular sleep schedules. In men, sleep restriction to 5 hours per night for 1 week reduces testosterone levels by 10 to 15%, equivalent to 10 to 15 years of age-related testosterone decline. Women are similarly affected in terms of cortisol dysregulation and reproductive hormone disruption. What is the solution? It is deceptively simple and genuinely difficult in modern life. 7 to 9 hours of actual sleep time in a dark, cool room at a consistent schedule is the non-negotiable foundation. Not time in bed, actual sleep. If you are lying in bed for 8 hours but taking 45 minutes to fall asleep and waking at 3 a.m., you are not getting the restorative benefit. The single most evidence-backed behavioral intervention for improving sleep quality is stimulus control therapy. Your bed is only for sleep and sex. No phones, no television, no working in bed, no lying in bed awake for extended periods. This reconditions the brain to associate the bed environment with sleep onset rather than arousal. It is the most effective non-pharmacological treatment for insomnia that exists. Sleep is not a luxury. It is a biological necessity with no substitute. Every hour you steal from it, your body pays with interest. Habit 5. Social isolation and disconnection. And here is habit number 5. The one I told you at the beginning that nobody is talking about. The one that, in my clinical opinion, may be the most dangerous of all. Habit number 5 is chronic social isolation and the absence of genuine human connection. I know that sounds soft. I know in a video about medical mechanisms and biological pathways, talking about loneliness might feel out of place. Bear with me. In 2023, the U.S. Surgeon General issued a formal advisory declaring loneliness and social isolation an epidemic with serious consequences for public health. This was not a cultural commentary. This was a medical declaration based on extensive epidemiological evidence. Here is what the data actually shows. A meta-analysis by Julian Lundstad and colleagues at Brigham Young University, one of the most comprehensive analyses of social connection and health ever published, analyzed data from 148 studies involving over 300,000 participants, and found that social isolation increases all-cause mortality risk by 29%. Poor social relationships are associated with a 32% increased risk of stroke. And here is the number that I want you to sit with. Inadequate social connection is associated with a mortality risk equivalent to smoking 15 cigarettes per day. 15 cigarettes a day. We have built entire public health campaigns around the dangers of smoking. We put graphic images on cigarette packages. We tax tobacco heavily. We restrict where people can smoke. But there is no public health infrastructure around loneliness, even though the mortality data is comparable. What is the mechanism? How does social isolation translate into physical disease and death? First, through the HPA axis and chronic stress activation. Humans are a profoundly social species. Our nervous systems evolved over hundreds of thousands of years in the context of tight social groups. Social connection signals safety to the nervous system. Social isolation signals threat. Chronically isolated individuals show persistently elevated cortisol levels, elevated sympathetic nervous system tone, higher levels of inflammatory cytokines, including IL-6 and C-reactive protein, and dysregulated NF-kappa B signaling, which is a master regulator of the inflammatory response. Second, through what John Cacioppo, the pioneer of loneliness research at the University of Chicago, called the loneliness loop. Chronic loneliness produces a threat hypervigilance state where the brain is chronically scanning for social threat and rejection. This heightened vigilance increases cortisol, disrupts sleep, impairs executive function, and paradoxically makes social engagement more difficult and anxiety-provoking, reinforcing the isolation. It is a self-perpetuating neurobiological loop that is genuinely difficult to exit without deliberate intervention. Third, through behavioral pathways. Isolated individuals are significantly more likely to adopt and maintain harmful health behaviors. They sleep worse, they exercise less, they eat more ultra-processed food, they are more likely to abuse alcohol and other substances. Social connection is one of the most powerful regulators of health behavior that exists. We modify our behavior in the context of social norms, social accountability, and the desire to remain healthy for the people we love and who depend on us. Fourth, through direct cardiovascular mechanisms. Social isolation independently predicts hypertension, arterial stiffness, and elevated fibrinogen levels, which promote blood clotting. Loneliness is associated with shortened telomeres. Chronic loneliness impairs natural killer cell activity and antiviral immune responses. The blue zone populations, the longest-lived communities in the world in Sardinia, Okinawa, Nicoya in Costa Rica, Loma Linda in California, and Ikaria in Greece, share several characteristics. Yes, they move more. Yes, they eat whole foods. But the feature that researchers identify as the most consistent across all 5 populations is strong, embedded social networks, a sense of belonging, and regular, meaningful human contact. Okinawans have a concept called moai, lifelong social support groups that form in childhood and persist across the entire lifespan. Sardinian men maintain multi-generational family bonds that are a central organizing structure of daily life. These are not incidental features. They are, according to the researchers who have studied these populations, the defining feature. The practical implication is this: investing in your social relationships is a medical intervention. Joining a group, showing up consistently for people you care about, having regular face-to-face contact with others, participating in community, being vulnerable enough to let people know when you are struggling, these are not soft life skills. They are physiological regulators of your immune system, your stress response, your cardiovascular health, and the rate at which you age. The master summary. Let's bring this together. Habit 1. Chronic, uninterrupted sitting. Break it every 30 minutes with 2 to 3 minutes of movement. Non-negotiable. Habit 2. Chronic stress without intervention. 5 minutes of physiological sighing or structured breath work daily. Treat it as a hard medical intervention. Habit 3. Ultra-processed food as a dietary foundation. Cook from whole ingredients more than half your meals. Reduce ultra-processed food below 20% of caloric intake. Habit 4. Chronic sleep deprivation. Protect 7 to 9 hours. Consistent schedule. Dark, cool room. Bed for sleep only. Habit 5. Social isolation and disconnection. Invest in your relationships with the same seriousness you invest in your physical health. They are not separate categories. None of these interventions requires a prescription. None of them requires a supplement. None of them requires a piece of expensive equipment. They require awareness, prioritization, and consistency. And here is what I want you to understand about consistency. You do not have to be perfect. Research on behavior change consistently shows that showing up 80% of the time, getting back on track quickly after lapses, and treating these as long-term commitments rather than short-term challenges produces the same biological outcomes as perfect adherence. Progress, not perfection. I want to end with something that I believe is worth saying clearly. The medical system is extraordinary at acute care. If you have a heart attack, a broken bone, a serious infection, a surgical emergency, modern medicine will save your life, and the people who work in it will do so with skill and dedication. But the medical system is structurally terrible at preventing the chronic diseases that kill the majority of people in the developed world. And the behaviors that drive those diseases are the ones I've described today. Sitting too much, carrying unresolved chronic stress, eating engineered food products, sleeping too little, and living without genuine human connection. Your doctor doesn't have time to tell you this. The system doesn't incentivize telling you this. But it is the truth, and it is backed by more evidence than most of the treatments you will ever be prescribed. You have more control over your long-term health trajectory than you have been led to believe. Use it. I'm Dr. Julian Cross. If this video added something to your understanding, share it with someone you care about, and I'll see you in the next one.